Hello and welcome to 1.2 Terrestrial or Land Biomes. These are the objectives we're going to be covering in today's unit. Alright, so first, what is the biome? Well, a biome is an area that shares a combination of average yearly temperature and precipitation. And that's average yearly temperature. Alright, examples are rainforest, taigas, that's spelled wrong by the way, temperate deciduous forests, tundras, desert, and grasslands. The community of organisms, which are plants and animals, that live in a biome are uniquely adapted to live in that biome, meaning they have specific traits that help them survive there. For example, camels and cacti have water-preserving traits for the desert. Shrubs and wildflowers store a lot of energy in their roots to quickly recover from fire in grasslands. Alright, next up, biome characteristics. So biomes are defined by annual temperature and precipitation averages. So over here we can see the annual precipitation on the y-axis, and it's increasing like this. But keep in mind that the average temperature right here is decreasing. So this is higher temperatures and this is lower temperatures. So over here we can see in the tropical rainforest it has high annual precipitation and also really high temperatures. Tropical seasonal forest will have medium amounts of precipitation and high amounts of temperature. A subtropical desert would have low amounts of precipitation and high temperature. It's kind of good to memorize the characteristics of these biomes or just memorize this kind of graph, and you'll have a really good method to figure out what a biome is based on just the temperature and precipitation. The biome chart can also predict where on Earth biomes are found. So over here we have a map of our beautiful planet, and from the equator to the 30 degrees north and 30 degrees south is usually the tropical biomes. And from the 30 degrees to the 60 degrees, it's usually the temperate biomes. And above the 60 degrees, it's usually the tundra biomes. So over here, we can see tropical is closer to the equator. So that's, like I said, from the equator to the 30 degrees on both sides. And then next is the temperate biomes, which are middle latitude. So 30 to 60, and then 30 to 60 here as well, but can't get that there. And the tundra and boreal biomes are the highest latitudes. They're above 60 degrees. Alright, next up we have the latitude, which is the distance from equator. So it determines temperature and precipitation, which is why biomes exist a predictable pattern on Earth. So that's why all these rules apply. It's because latitude determines temperature and precipitation. Alright, next up, nutrient availability. Plants need soil nutrients to grow, so availability determines which plants can survive in which biome. For example, frozen soils of tundra don't allow nutrients in dead organisms matter to be broken down by decomposers. So low soil nutrients, low water availability, all that means few plants survive there. A tropical rainforest is nutrient-poor soil because there's so many competitions from so many different plant species. A boreal forest is also nutrient-poor soil, but instead it's because of low temperature and low decomposition, which is basically the rate of dead organisms matter turning into nutrients for the soil. Next is the temperate forest, which is nutrient rich. There's lots of dead organisms matter, which is from leaves usually, and there's warm temperature / moisture for decomposition. Next up, a climatic graph. A graphical representation of a location's basic climate. Climatic graphs display data for two variables, monthly average temperature and monthly average precipitation, which is, if you remember, what you use to calculate the climate of a region and what biome it's in. Quickly describe a location's climate. You're definitely going to have to read one of these for the AP test. Next up, shifting biomes. Biomes can shift in location on Earth as climate changes. For example, a warming climate will shift boreal forests further north as tundra permafrost soil melts, and lower latitudes become too warm for aspen and spruce trees. So here you can see a map of shifting biomes. So first over here, that's the survivability zone of aspen, but the projected version, it's slowly increasing more and more north. Here's a more recent example from images in 1962 to images in 2004. Anyways, that's our different stuff explained, and that's all for this video. Hope you guys have a great day and do well on your tests.